All right, so chapter 14. So this is another chapter on probability, and this one's talking about random variables. And so this one's a little bit different. 12 and 13 are pretty closely related. 14 is kind of moving on to something a little bit different, but still probability. And we still kind of need to remember maybe not so much the vocabulary from the previous chapters, although of course, it's still important. But more we need to pay attention to what these problems look like as opposed to the problems that were in the previous chapters. Because again, most of these are not going to take very much work to do, but figuring out the proper method to doing them is the trick. And then once you do that, once you know that, then it's easy. All right, so this one starts with random variables. So a random variable is it's a variable, assumes a value based on the outcome of a random event, or you could say it associates a number with a random event. So for instance, flipping a coin is not a random variable. It lands on heads or tails. That's not a numeric value. But if you say flip a coin, if it lands on heads, pay you $10. If it lands on tails, pay you $5. Now we have numbers associated with the random event. So now that would be a random variable. We use capital letters like X to denote the random variable, and then a particular value will be denoted by lowercase x. Then we have two types of random variables. So we have discrete, where we can list all the possible outcomes, so number of credit hours, number of people in a group, anything that you can count like that. And then continuous random variables are more like scientific measurements. A lot of times those are going to be considered continuous, so time to run a race. And the reason is because you can keep dividing the interval up. So you either have one person or two people or three people, but you're not going to get 1.5 people or 2.5 or anything like that. With the continuous random variables, you can continue to incrementally divided, up. So it's not just a countable thing. Then we have a probability model. So the probability model is just a collection of all possible values. Typically, we're going to be doing this with a discrete random variable, so we can list all the outcomes and then the probabilities that those outcomes occur. And then expected value, that's just going to be like a weighted average. So we'll do an example, and this will hopefully all make sense. So we have a restaurant, Valentine's Day, is going to offer a discount. So the couple will draw a card, and then based on that, they get a discount. And so you can see here, if they draw the ace of hearts, they get a $20 discount. There's a 1 in 4 chance of getting the ace of hearts. And then ace of diamonds, if they draw the ace of diamonds, they draw another card. And then if they draw the ace of hearts on the second try, then they get a $10 discount. If they draw the black ace, then they get a $0 discount. So what we can do is we want to find the expected value of X. And so we're just going to take each of these values, multiply it by its probability, and then add them all up. So we have 20 times 1/4 plus 10 times 1/12 plus 0 times 2/3. And so we add all those up and we get $5.83. And so what that means is over a long period of time with hundreds of customers or thousands of customers coming in over many weeks or however long that would take, on average, the average discount would be $5.83 per customer. And so that's what expected value means. Over many trials, what would be the average of that variable? All right. So next we have variance and standard deviation. So variance is a measure of spread. It's denoted by sigma squared. And if you remember, we denote standard deviation by sigma. And so variance is literally just the square of the standard deviation. Standard deviation is the square root of the variance. So that's their relationship. And typically, well, always on these problems, we are going to have to find the variance before we can find the standard deviation. And so the way we find the variance is by this formula. And it's not super difficult, but it can be a little bit tedious because it's mostly just plugging things in the calculator, and so it's, you have to be careful that you're not miskeying something. So we're going to find the standard deviation of the discount in the last example. And so we need to find the variance first. So you can't find the standard deviation directly. You have to find the variance first, and then the way we find the variance is we find these two things. So this expected value of x, that's what we found in the last part. So that was the 583 that we found earlier. Now, how do we find the expected value of x squared? So it's almost the same thing as what we just did, except we're going to square all of the x values and multiply them by their probabilities. And so when we do that, we get 108.33. And so then, of course, from the last example, the expected value is 580. And so the expected value of x we found earlier is 583. And so now we plug both of these in to the variance and find the variance. So the variance of x, and like I said, I think I said this in the previous video, but one of the videos recently, if you want to learn a formula, you write it down every time you need to use it, and don't plug it in until you write it down. That will help you to memorize it. So expected value of x squared is this 108.33. And then minus the square of the expected value. So that's 583 squared. And we plug that in and we get 74.3444. And then to get the standard deviation, all we're going to do is take the square root of the variance. So the square root is 74.3444. And that is 8.62. And that is the standard deviation. All right. So that is how you do those. And obviously, these two require a little bit of, punching numbers in the calculator. And so you have to be very careful and make sure here that you're only squaring the x value. You do not square the probability. So the probabilities stay the same no matter what you're doing with the expected values of whatever it is. And just carefully do that and make sure you know this formula. And it's really not that difficult once you've done it a couple of times. It's not going to be that hard. And we're not going to have long, dozens of x values that you have to enter in. So should be fairly simple. So let's talk about continuous variables. And so this is basically going to be a review. So when we did chapter 5, I said that chapter 5 is pretty foundational, and we're going to come back to it. And here's where we're going to come back to it. And then we're going to see a lot more with normal distribution in the chapters to come. So this is an example of a continuous random variable. Temperature would be considered a continuous random variable. So it says the average daily temperature in a city during summer follows a normal distribution with a mean of 78 degrees, standard deviation of 5 degrees. What is the probability that on a randomly selected day, the temperature is more than 85? So this is a chapter 5 problem. And so if you remember from chapter 5, you draw the normal curve. You're going to put the mean in the middle. So the mean is 78. And then you're going to you don't have to worry about labeling the standard deviation on here. You're going to label the 85. So you label the 78 and the 85. 85 is going to go somewhere up here. And then you have to shade one way or the other. So we're going more than 85. So we're going to shade this way. And then on the calculator, and if you need to, there's a video on back in chapter 5 where they show you exactly how to do this. I'll just say it and go from there. So we go on the calculator, second bars. We're going to pick number 2, which is normal CDF. and then you put your lower bound of the shaded area. So the lower bound is the left side of the shaded area. That would be 85. Upper bound, put some big number. I just put 1 and then a bunch of zeros, however many you want to put. I would put more than 2 though, but at least 3. And then next is your mean and the standard deviation. And when we put that in, let's see what we get. We should get 0.081 for that. And so that, again, the reason for the picture is so that you can see, assuming you draw your picture correctly, you can see that that's not going to be a high percentage that we have shaded. So the whole curve makes 100%. We've obviously not shaded that much. And it's not going to be, you might say, well, that looks like more than 8%, but that's not the point. The point is, it's not going to be 70% or 80% because this is making up a big chunk of it that we're not counting. So the idea of the picture is just to kind of give you a ballpark range of where your answers should be. So I would always recommend that you draw the picture. And it also helps where, which is your upper, which is your lower bound, that kind of thing. All right, so then the last one, just another similar problem to part A. What is the probability that on a randomly selected day, the temperature is less than 75? So we're going to put the mean in the middle again. 75 will be somewhere over here. And then less than, so we're going to shade this way. And same thing, second bars, we're going to go to normal CDF. The lower bound over here will be 0. Or you could put negative 1,000 if you want. You could put a negative big number if you're going that way, but obviously 0, well, 0 is at the lowest temperature, but 0 is far enough away. You can put 0. Really, the whole point is if it's one of these areas that you don't technically have a lower bound, pick a number that is very far from measured in standard deviations. So 5 standard deviations, you get 1 standard deviation, 2 and 3 standard deviations. That's almost far enough. So just go far enough away is the point. Then you put your mean and your standard deviation, and let's see what we get this time. And we get 0.274. 274. So these problems are exactly the same as back in chapter 5. So if you're good with those, then should be a quick little review, and you should be good with them now. And again, we'll be doing normal CDF things more as we get into the third test as well. But it's a pretty quick chapter, and so hopefully this will be not too bad for you. But if you have any questions, feel free to email me. Let me know.